at highest point. What is the state of hemisphere? Hemisphere is in motion. You can see this one. Even we are will permit the hemisphere to move. What is the condition? Condition to leave circular path at highest point. What should be the velocity of the block with respect to hemisphere? Should be greater than or equal to root gr, no? The v relative should be greater than or equal to root gr. What is v relative here in this case? V minus of plus v1 minus of plus v2. So what is the velocity this one? v1 minus v2 root gr. So what is the velocity v1? This should be equal to v2 plus or v2 plus root gr. If the velocity is greater than or equal to this, it's going to leave the circular path. If the hemisphere also given a motion, what is v1? This should be the velocity of block. Velocity of hemisphere is given for us. Now similarly, if it is some relative motions can be asked, you have to be careful. Okay, now if I give the velocity to the hemisphere towards left, what are the conditions for this? I think from the relative velocity concept, plus v1 minus of v2 greater than or equal to root gr. So v1 should be equal to greater than or equal to root gr minus v2. If it is greater than or equal to root gr minus v2, it is going to leave circular path at highest point. So what is the condition required? The condition required, I am showing the path. Simple relative velocity concept is what you are supposed to apply. Some matchings or somewhere they will ask you a question like this. Nothing new. If the hemisphere is attached, okay, we know root gr to leave at minimum velocity required to leave circular path highest point. If the hemisphere is in motion, we are going to bring the relative velocity. This is the velocity with respect to ground. What is the absolute, what should be the velocity of the block relative to hemisphere? Should be root gr. With respect to ground, it should be this one. So what are v1, v2? What is v1 we should define? How you define v1? Velocity of block with respect to ground, so that it leaves circular path at highest point of the hemisphere track or circular track. Okay, now all together there's a one basic idea. The hemisphere can be rest or in motion. So can we discuss the problem? Yes, we can use this basic method. Any doubt if you want, you can clarify. What is the application of this? Any design of arms on the road, some sliding equipments in the park. I think we have to be very careful enough, no, not based on design. The science involved has to be understood here. So some of you will become architectural engineers. See that, okay, please do follow the rules of science and bring the designs. The design should be not against the science. Okay, now we'll go for the next one more application of vertical circular motion.